back online. Let's see. One thing I want to do is set real-time mode to off, because people don't usually interact with me. If you want, I can change that. But you know what? Screw it. So one thing I've done in the last 30 minutes since my last session is I spun up a nice new EC2 instance for doing this, so that stuff can run faster. It's got, 8 fake CPUs and virtual CPUs, and can run the test suite in a minute and a half. So that's going to be a big improvement, I think. So let's see. Last time we were working on something like we were working on some off by one issues in the API code, and I came up with something a little bit sad, which is this. I just called this function static size 2, but really what we need is to call it something else, because that's not really very helpful for people. So I think what we're going to call this is we're going to call this embedded static size, and we're going to call this static size. I'm happy with that. And I think embedded static size is always going to be something like, actually we need to switch these around. General, it's like 32 if self dot is. Let me make else self dot static size, because that's how the embedding works. But we're not at that stage yet, because there's a lot of code that depends on embedded static size being the wrong thing. Go figure. So I don't want to break too much stuff yet. See, like, oh no, that's fine. Static size 2. Oh, and now we're going to need to rename everything. That's fine, that's fine. That's also fine. That's not fine. This is static size, and this is embedded static size. Return 32 if self dot is dynamic. Else self dot static size. Else self dot static size, and we're going to rename that. I'm starting to sense a pattern here, so maybe we don't need to implement this at all, but maybe we can just always rely on this but it's going to be really broken for like byte array. Because this, like the truly correct implementation is like embedded static size self is return 32 if self dot is dynamic else 0, and it's always going to be always 32, and then def static size self return 0, because that, you know what, why don't we do it the right way from the get-go. So let's get rid of this static size 2 function, or not get rid of it, but just use the correct thing. Yay! And now we can all sleep better at night because we know this is going to break whenever we have a logical error. Okay. Now, that's what we want. Sorry, we just have to switch all the things around. This is the part where we have to keep our heads on straight. So wherever we had static size 2, now we want static size, and wherever we had static size, now we want embedded static size. Yep. This is decode, so we want embedded static size. And I feel like we almost want this to be the embedded static size only if the parent is a tuple. Whatever. This is another embedded static size. Okay. No, that's not what I want. I need to fix my git config. Git config. No. Oh. Just copy this shit. Oh, it's because I don't have my dot files on this machine. Whatever. We will live for now. Rename static size to embedded static size. And what we really want to do is rebase this, squash a few things. We'll just fix that up. And then we need to fix all the external calls. Now, okay. I think if I fix all the ones in there, we need to fix these things. Static size 2. Nope, just that one. And we're going to fix this up too. Fix all the ones in API, and we haven't fixed the one in external call yet, but that's because that's in a different commit. Okay, let's fix this commit. Static size 2. And we'll just amend that directly. And now we're going to test, check out this thing. PyTest with parallelism of 7. Oh, we got a failure. Let's check it out. Of course we have a failure. Not implemented. Really? ABI bytes does not have that implemented. Did I? Oops. My bad. Def static size self return 0. Yeah, I guess, note that static size for, dynamic types is always 0, and embedded static size is always 32. I feel like I'm making this confusing somehow, but soldier on ahead until something shows us the error of our ways. Oops, no. Want the 7 cores, not 4 cores. I wish I could play some music, but apparently they really don't like it when you stream Spotify or something about copyright. But I wonder if if the quality is low enough that they just won't care. What's going on now? What? Why won't you tell me what failed? Ooh. It might be my new external call code, so I want to, just for security reasons, let's toss that commit out for a moment. And that's going to save a little tag, whatever. And then we set this. And then we're going to test it again without the external call code. Then the interesting thing is we can see review what I did while we're waiting for that. Oh yeah, we have some memory, some location errors. I think that's all fine. Can you show me which test was failing, please? There we go. Could not decode this thing. How do you find the hex for a character? Oh, that doesn't do it. Okay, so the only thing to do is literally compile this. And see what it does. Mixed arg list bytes call. Oh, do you see what this is doing? This is exactly what I was afraid of. It's returning a bytes thing. And that's gonna have like the wrong size. And I think I know what I need to do for this, which is if it's a base type, I need to wrap it in a tuple. Return types are always tuples, even if according to the API. Actually, I want to double check this. Even if only one element is being returned. Return. And the return values are encoded as the values are combined into a tuple and encoded. And I'm going to quote this because it's very confusing behavior. And everybody should have a right to clarity. equals, oops, we're always going to wrap it in tuple. Okay. I think that's going to cover all of our bases. Oops. And then we're going to commit that change. Always wrap return data in tuple. It is not already. Run the test, cross our fingers and pray. No, we got a failure. What is it? Bad function call output. Assert C dot bar. Okay, let's just compile this and see what happens. I don't have syntax highlighting yet. Okay. There we go. Completely frozen. My computer is frozen. Okay. Let's see what this actually does. So foo z returns z. Foo a returns a. And foo x returns x1. So what we're going to do instead, just to kind of make this output more bearable to read, is we're going to return z, a, and x1. here. We're going to get a lot of stuff. Here's our return buffer. Create hello world. Cool. Cool beans. And the thing about this is how big the buffer is going to be. mload 192, right? Where do I put in 192? Oh, right. So with this, and the dyne offset is 64. And that's really wrong, because it should be 96, because there should be an offset word. Yep, static size is really wrong because for tuple, embedded static size this needs to be embedded static size. There's my mistake. And we're going to inspect the output again. And voila. We got the right output now. Just gonna, squash that into the fixed static size calculation commit and rerun the test suite. I think this might actually work. Yeah, I think we're cooking with gas. So this thing that I did with the wrapping the thing in a tuple, I want to turn this into a function called ensure tuple. ABI type equals ensure tuple ABI type. Yeah, cool. Test passing. Ensure tuple API type. because there's a lot of places, there are a lot of places in the ABI, in calling convention where a tuple, not a pool, a tuple must be passed. So here's a convenience function for that. Oops, what happened? Oops. Let's try that again. Okay, I think that more or less did what we wanted. I'll leave the test running, but what I want to do now is continue where I left off on decoding output data. Thinking about now is that lazy ABI decode always takes a Vyper type, but we might actually want it to take an ABI type, so that we can do the same ensure tuple trick before we call lazy ABI decode. But let me see if there's another way we can deal with that. So let's check out our ref log. Are we in git cherry pick? That's what we need. And just to remind ourselves of where we are in this. Oh yeah. So I think the confusing thing about this is, oh yeah, well, we need to, normally we put the returner on the stack, but since decoding something in the ABI could return like this multi thing, we actually don't want to return it on the stack. We want to pass around a little LL object. This thing. Thinking about how to attack this. I'm pretty sure there's going to be some tests that'll fail. The first thing I want to deal with is making sure that we can wrap the type in a tuple. So let's make a little convenience function for that. You know what the interesting thing about it is that maybe it always needs to be wrapped in a tuple, even if it already is a tuple. That's a little weird. Well, I don't think that's how that works. Attribute error. Int object has no attribute location. I thought I already fixed this. Okay. You know what's interesting is that when we make a call, we're always going to return the output value on the stack. But now I'm thinking that we might not even want to do that. We should just make the call and then keep track of where the buffer is, the output buffer, and then only actually read from it on demand. Because that actually causes a lot of problems. Like when we make an external call, stuff will get pushed onto the stack and it's not necessarily consumed. And that's not something that we really want because it could mess up like what the compiler thinks. It's a little harder to reason about what's on the stack. So if we don't return what's on the stack and we just keep track of the pointer to the output buffer, that could be a little cleaner. Especially like here, this is a statement call where we have something like we just have a line which is a call, like we're in a function, right? And we're like call external, or like foo dot call some function. And like here, obviously we never want to decode the output data because we're not using it. The user didn't ask to see it. I'm gonna not think about that for now and fix this location error. Let's see. What is the code that causes this? That looks like it compiles okay. That also looks like it compiles okay, so it must have been the other contract that it didn't like. What was that? Invalid location none. Yay. There must be a way to set the location to none because we have literals all the time. The location is none, so why isn't it happy with that? Oh, because it's an int, it's not a literal thing. I don't even want to put the returner in here because it, like, is not needed a lot of the time. Where is it needed is when we have, like, a call expression. Sorry, I'm thinking a lot about what to do right now. List type has no attribute subtype. Really? Thought I did. subtype with an E, I can deal with that. Just keep working through these test failures. Not expecting an array access. Because the location is none. Not expecting a member variable access. Some of these error messages are terrible. Expecting a member variable access. How is that happening? In add variable offset in make setter. Let's just see what is actually in here. It's throwing on. Parent key. X. Why is it not expecting a member variable access? Because it doesn't have a location. And how do we actually deal with assignment. What we're going to do is we're going to make an expression out of the right side, right? Let's call it and assign, okay. And we take the right hand side, turn it into a triple L node, and then we run make setter on the right hand side to the left hand side. I thought I got rid of this line a long time ago. Oh yeah, probably once I rebase and all of that. Now is probably a good time to rebase because I'm starting to like write all over the rest of the code base. But I want to figure out how we're going to deal with this lazy ABI decode thing. Because I want to shift it into somewhere where the caller calls ABI decode when it needs to. Not like it always happens and then the result gets pushed onto the stack. You know, what we could do is we could push the output buffer location onto the stack, but tell make setter that it's like something special. Tell make setter that it's not actually a real thing, it's actually a multi. Okay. Actually, all we need to do is just always pass the location of the, because the location of the lazily ABI decoded stuff is just going to be the location of the buffer that's being decoded. Type source. And I guess we're assuming that we always have a location. So location equals source dot. Location. Let's just add a little bit of white space here. And then see if that does anything for us. No. Awesome. Why? Is the parser external call lazy ABI decode? We need to make sure that the output placeholder, yeah, it's got a location. What's wrong? Killing me. Location. location is memory. So maybe the children also need to get the location. I think I can do that. That's going to make this a little bit confusing. So here where we have lock, we're going to call it pointer. That's fine. Like, what happens when we unwrap location? Like, this has no location either. So maybe we should just literally not unwrap the location and see what happens. That doesn't seem right. But it's just gonna be... What? Printf debugging now. Location none. Why? Just print everything, I guess. So when it's on the right side, and we're in make setter 741. Oh. Yikes. It's because it thinks it's not picking up the multi. Yeah, this is exactly what I was afraid of. So what's happening is what's happening is the whole right side is getting wrapped in this big seek statement, which I really am a little bit sad about. I wish there was some way to pass it up, pass, the call statement and the ABI decode statement separately. Encoding is overloaded. I don't know what's wrong with my computer. One solution I'm thinking about is instead of returning the lazy ABI decode stuff, instead we can have a special flag that we pass to make setter that tells it that the right hand side is ABI encoded. I think that might be pretty slick. And then instead of trying to figure out like where to pass everything and changing this entire control flow, we just set this flag and then make setter it's still not great. But it's a little better. I'm gonna need to think about that for a little while. And maybe